This lesson we're looking at our perimeter of circular and composite shapes. So we need to remember that our perimeter is the distance around the outside of our shape. And to find our perimeter, we add all of our sides together. So sometimes what we need to do is we need to find these missing sides. So if this whole length here is 10 and this is 8, this part here would be 10 minus 8, which would give us 2 centimetres. This measurement, I've got 15 down the bottom here, 9 here, so 15 minus 9 would tell me that that is 6 centimetres. And to do the perimeter then, I would say P for perimeter equals, I'm going to say 2 plus 6 plus 8 plus 15 plus 10, plus, not times, plus 9, work that all out, and that gives me 50 centimetres. Be sure to put those units on the end, as it can cost you marks if you don't do that. Now with B, I have a missing side that I need to find, and I can't find it just by doing these subtractions like I did in the first one. So what I'm going to do here is I'm going to pretend that this is a right-angled triangle. Now I know that the height of this triangle here is 4, and to calculate this side here, I know that this whole measurement is 10, this is 7, so that means that this part here is going to be 3 centimetres. Now those of us who are quite familiar with our Pythagoras would be able to determine that this side is then going to be 5 centimetres, but if it wasn't as clear as this, we would then have to use our Pythagoras' theorem in order to find that missing side. So if I put that in, I would have 4 squared plus 3 squared, which is 16 plus 9. So I need to find the square root of 25, which gives me 5. Okay, with having that, I can then calculate the perimeter of my shape. So I have 10 plus 5 plus 7 plus 4, which gives me 26 centimetres. Again, being really mindful to put those units on the end. So they're our rectangular, easier shapes to work out, I would say. Then we go into our circular shapes. So when we talk about the perimeter of a circle, the perimeter of a circle is actually called the circumference. And when we look at the circumference, there are 2 formulae you can use. You could use C equals pi d or C equals 2 pi r. Now, our diameter is our whole way across the circle, and our radius is from the center of the circle out to the edge. So please make sure you know the difference between the diameter and the radius. When we find or use a circle and we're finding maybe a part of a circle instead of a whole circle, we need to find the length of an arc. So the length of our arc is the angle that it is over, so the angle of the circle, over 360, because there's 360 degrees in the circle, multiplied by 2 lots of the radius times pi. And that's what all of this is telling us. So if we look at our examples down here, we don't have a full circle because we've done this before. That's just a little bit of a recap. So we're going to look at our part of circles. So for A, we need to find the length of the arc. So this is a semicircle, so we can just say half, okay, multiplied by 2 times pi times the radius. Now here, the radius is half of what this is, because this is giving us our diameter, so times 5. If we put that into our calculator, it actually comes out as 5 pi, which is our exact form if you're ever asked for that. But if we want to round it, we're going to get 15.70796, whatever that could be, continuing on. With these, it's really important that if you've typed this in and you get to this answer, we don't want to round it just yet, because if we round it, it can make errors in the future. It might mean that our answers are out by 0.1 or 0.2. So it's either keep it as 5 pi or don't clear your calculator, and you can just then do the next part by adding on to this number here. So what I then need to do is find the perimeter. So the perimeter is this number above, all of that number, plus, because that only has found me this part here. This is our arc. I then need to add on the diameter, so plus 10. So we get 25.70796 forever. If we round that to 1 decimal point, we get 25.7 centimeters. For B, this time I still need to find the length of my arc. Now I have a quarter of a circle. So I can go 1/4 times pi, times 2 times pi times my radius, which is 12. So if I were to type all that into my calculator, this will simplify down to being 6 pi, or if I have it as a decimal, 18.8495. Continuing, again, don't clear the calculator. I then need to find the perimeter. So I have this number here, and then I need to add my other two sides. So this is my arc, this is my 18. I have two other sides to add on. Both of these sides are 12. So I'm technically adding 24. So from there, I'm then getting 42.8495. And if I round that to 1 decimal place, I get 42.8 millimeters. And our last one here, we now have a part of a circle. So I'm still finding the arc length. This time I don't have like a quarter or a half, so I have to use the angle that's there. So 54/360 times 2 times pi times the radius, which is 6.4. If I punch all of that into my calculator, if I want to keep it as my exact form, this is what I end up with, 48/25 times pi. If I want it as a decimal, I get 6.03 continuing. So remember, that's found just this part here. I then need to find the perimeter. So the perimeter is adding all of my sides together. So I have the arc. I then have to add both radius. So I get plus 6.4, and I get it twice. So I'm adding 12.8. So if I put all that in, again, without clearing my calculator, I get 18.831 continuing, which if rounded to 1 decimal place would give me 18.8 centimeters. So the biggest point here is do not round your answer here. You round at the very end when you've finished and all of your calculations are done correctly.